electron for phosphorus is going to be 5 valence electrons, and for fluoride it's going to be 7 valence electrons. However, since it is PF5, that means we have 5 fluorides, so we're gonna multiply 7 times 5, which is going to equal 35. 35 plus 5 is going to be 40 valence electrons total. So when we draw our Lewis structure, this is going to be important because all of them, to add all of them up, have to equate to 40 valence electrons. So we're going to draw phosphorus in the center, and it's going to be fluoride. Obviously, phosphorus is one of the elements that actually gets satisfied with more than 8, or it could break the octet rule. So here we go. So it's gonna be 5, 1, 2, 3, 4, 5, 2, 4, 6, 8, 10. So we already got rid of 10. So now we have to draw 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24, 26, 28, 30, and 30 plus 10 is going to be 40. So this is our Lewis structure, and this is a trigonal bipyramidal. So this is what it looks like down here, bottom half. And I will be redrawing it in color, the right shape. And then let's go back to the methane because I didn't do the shape. Carbon is going to be represented by this red one, sorry. Center is going to be carbon. Sorry, ran out of red gummies. So here we go. And this is what this one looks like. This is methane. Red represents the hydrogens, orange represents the carbon. And this is how it would look from the bottom. So it's 3, and then it stands up on its own. Oh, it should stand up on its own, but my little sticks aren't really properly measured. So then, which one are we doing next? So we're doing the phosphorus pentafluoride. So it's just going to be fluoride, phosphorus. So it's going to be fluoride. And then, sorry, I'm trying to do it 3D. Let's see how this works out, because I'm not really a great artist, but I will try. And then, that really hurts. So fluoride is going to have a negative charge. Phosphorus pentafluoride is also a nonpolar molecule. I don't know how I came up with all nonpolar molecules. However, it is a polar bond. But due to the symmetrically oriented molecule, like the shape of it, it is non-polar molecule. So it is going to retract from the center because the center phosphorus is positive. So I'm drawing our polarity arrows in blue, and you'll see them right now. And it is a non-polar bond. So this is what it looks like. And this is the Lewis structure, valence electrons, the name of the shape, and it is non-polar. So moving forward, we're gonna draw, and we're gonna create the molecule. See how this works. So for phosphorus, we're gonna do orange, so it's gonna be the center. Fluoride is going to be purple. Let's see if we could. Let's try to do this, see how this works. So fluoride is purple. Here's two fluorides. And then here's the third one. Here is the fourth one. And then here is, let's see if I can get it. Here is the fifth one. So this is phosphorus pentafluoride. As you can see, this is what it looks like at the bottom. Sorry, it's not even. I'm trying my best. So here's this one. Last but not least, sulfur hexafluoride. It's gonna be SF6. So sulfur, as I said before, it has a total of 6 valence electrons, and fluoride has a total of 7. So it's gonna be 7 times 6, which is gonna equal, so if you add them up, it's gonna equal 48 valence electrons. The Lewis structure for this is going to be, sulfur can also break the octet rule, so it doesn't necessarily have to have 8 to be satisfied. Let me just draw here. So it's going to be fluoride, 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 and fluoride. So this is the octahedral shape. It is also a non-polar molecule. I really went with non-polar molecules. I didn't even realize that.